name is Devajyoti Vishwas, and I'll take the week 2 live sessions. So let us start. So what we will do is we will, as you have seen, I think many people have already seen the, the what do you say, the lecture videos, and so can everyone? I think Ranjit, can you mute yourself? I'll mute you. Yeah. Okay. So we will start by going through the collab. Okay. We'll see the activity questions, practice questions if possible. And after that, we will both data visualization as well as the data pre-processing we will look into. And after that, we will see how much time we have left. And based on that, we can discuss other things. So, mhm. Just wait for a couple of minutes. Okay. So at first we saw data pre-processing techniques. So there are two parts in the week 2. One is data pre-processing, another is data visualization, right? So again, data pre-processing has different techniques involved in it. So there is data imputation, there is feature scaling, polynomial features, and feature hashing, dict vectorizer, and so on. Lots of things are there, and I think you have seen the this thing also. You have seen 1 minute. And you have seen, I think you have seen the search collabs as well. Okay, search slides as well, the slide deck as well. So I will go to the slides also, and I'll go to the collabs also. Let me see what we can go at first. 1 minute. Mm, so let us begin with the slides maybe. Um, so we have data pre-processing slides. So what is there is that firstly you should know that there is a library called SKlearn, which is important for for doing all the data pre-processing and visualization works. So whatever you feel necessary, if you feel some problem with the code or even with source code or with anything, if you have any doubt, you can know more about the codes with SKlearn in the SKlearn manual. So just search in Google with SKlearn, say feature hasher, SKlearn dict vectorizer, SKlearn this, SKlearn that, and like that. Okay. So that's how, I mean, you will go to the, let me see whether I can do it here. So if you have SKlearn One Hot Encoder. Okay. So we have seen in the in search lecture this week that there is something called SKlearn One Hot Encoder. Okay. So I'm sorry, it is taking some time. So by that time, let us see. So one thing which we have done is that, so SKlearn, there is a need to pre-process the data, of course. Okay, let's see. So if you go to sklearn.preprocessing.one hot encoder, which is the scikit-learn manual, if you go there, okay. So what you will see is that, let me show you. So you can see various aspects of SKlearn One Hot Encoder. Okay, so One Hot Encoder, you have different attributes, different parameters which you can use, and what are the different sets of it that you have to you can see, and you can see different solved examples. Okay, illustrations which you can utilize for your own purpose, for your understanding. So different code lines and code snippets are given, okay, which will be helpful for your understanding and for exam purposes as well. Okay, so someone was asking in the discourse about how we can use fit and fit transform, what is the difference between them. So you can check all those things from here. Okay, so this is the best resource which we can provide, which we have seen. I have at least seen. So scikit-learn manual. Whenever you are in a doubt, please check in scikit-learn manual first. Okay, anything which is related to, and in this course we will deal with scikit-learn only. Okay, mostly scikit-learns we will deal with. TensorFlow Keras we are not dealing with. Scikit-learn only we will go at least till whatever, I mean, week 8, so at least as far as I remember. Okay, so mostly so scikit-learn you should learn properly in this course. You will learn properly in this course. So previous week we have seen about data loading. How can we load the data? Maybe from read CSV, right? If you have a CSV, you can just read it with the command read CSV. If you have a data which is already available in online, you can just say load the data set, maybe load IDs data set, load California housing data set, etc. So this library names, the suppose the from where do we import one hot encoder? Okay, so suppose here you see from SKlearn.preprocessing import one hot encoder. Okay, so from which library do we encode? Do we import the one hot encoder? That will not be asked in your quiz. Okay, but in your online proctored exam, practical exam, OPPE, there you may be asked to write the code, and in your Viva also you may be asked to write the code. You will be asked that please apply one hot encoder and solve the process. So it is better if you practice well, and if you can and with practice it will come to your mind. It will be just at a moment's notice you can say that from SKlearn.preprocessing we can import one hot encoder. Also there are other things. So there is a pipeline, there is something called dict vectorizer, feature hasher, all those things are there. So similarly you will be expected to at least remember a few of them. Okay, in quiz they may not be asked. In quiz they may not be asked. Okay, in quiz obviously we won't ask you all those things. So sklearn has different preprocessing techniques, and it provides pipeline for making it easier to maintain multiple transforms together. So if you want to apply, say, one hot encoder, then on top of that you want to apply min max scalar, or you want to apply KNN imputer. So you can string all those things together, you can combine them together, and you can apply them uniformly as a single pipeline across the training, evaluation, or test sets. So what else is there? So yes, so typical problems. What are the typical problems in the data sets that we see? One is, of course, there are NaN values or missing values in literature in the data set, which you can solve with your, what do you say? Can anyone tell me how do we solve the missing values? What do we do with it?
Impute.
Impute. So we have three types of imputer. One is a simple imputer, one is a KNN imputer. In simple imputer, we have a mean, median, etc. strategies available. Then we can have numerical features which are not on the same scale. So what can we do? We can scale them in a particular manner. Categorical attributes need to be represented with sensible numerical representation. So of course, suppose you have a data set, okay, where in a restaurant where I was seeing a data set called tips data set. So it is basically in a restaurant how much tips are given when a person is having lunch and dinner. So suppose there is only one column which has the time, and there is only lunch or dinner, which is a categorical attribute. But you can combine it, you can represent it with numerical values. Okay, so suppose lunch is 0 and the dinner is 1, or dinner is 0, lunch is 1, whatever. And so with that you can represent the categorical attributes with numerical values. So there are one hot encoder and other encoding techniques which are available. Yes, so you can, if there are too many features, you can reduce them. So you can select k number of based features. You can select a particular top 10 percentile or top 30 percentile of features. Okay. And so you can reduce the unimportant features. What else? So yes, so these are the libraries which we have generally: SKlearn.preprocessing. We have SKlearn.feature extraction. We have SKlearn.decomposition, kernel approximation. All those things are there. Okay. So there is a difference between fit and transform. So fit method only learns the model parameters, whereas transform applies the transformation techniques to the new data. And fit transform is obviously the combination of fit and transform both, where it will just it will be more convenient and efficient to use. So it does the work of both fit and transform together. For feature extraction, we have three techniques. So one is dict vectorizer, one is feature hasher. So we will go through this when we are going through the collab. Okay, obviously we will see the programs. So we have, you see, we have different. So suppose we have dict vectorizer. What does it do? It converts the list of feature values into a matrix. So here you can see if we have a particular column, so age column has 4 values, 4, 1, 3, 2, and height column also has 4 values, 96, 73, 88, 81. So what it will do is it will create a matrix. If you apply this this code snippet on it, it will create a matrix. So 4 corresponding value is 96.0. For 1 corresponding value is 73.9. For 3 corresponding value is 88.9. For 2 corresponding value is 81.6, and so on.
So then there is one doubt, sir, here. In this dict vectorizer, it has to be a list of dictionary. Only then it will be converted.
Yes, I think so. It has to be a dictionary, because it is dictionary it is using. We can check. Let me check whether I can provide you a solution immediately. So dict vectorizer. Okay. Yes, so it turns list of mappings, dict like objects of feature names, to NumPy as a spy or sparse matrix. Okay.
Right.
Mm-hmm. So basically, as I was telling, I mean, this is the best resource. Okay.
Right, sir.
I mean, yeah, please. Yeah, I mean, no, I mean, yeah, obviously, to everyone. So whenever you face any doubt, please see this manual. Okay, this is a very nice manual from original SKlearn. So obviously, that will be useful for us. Okay. Anyway, I think many of you already know and have used this, so it will be not new knowledge to you, but still, if someone does not know, please use SKlearn manual. Okay. So in feature hasher, we have a high-speed, low-memory vectorizer. We have a discourse post on this today. Just we were discussing about feature hasher. Please follow it. It is a very nice post. Someone has posted. So feature hasher applies a hash function, and it is used in case when we are strapped for memory. We do not have much memory. Okay, then it uses hash function, and I think it applies a function called murmur hash 24. Okay, something like that, and it will it will make a sparse matrix which has low space, which requires low space, and it will
sir,
do the
question.
Yeah.
Sir, both of these hashers and vectorizers, why are we using these again? I didn't understand.
So feature hasher does what? Feature hasher and dict vectorizer, they all create matrix from the list. Okay, so if you have a particular list, okay, or a dictionary like object, then what they do is that they create a matrix from those data sets. Okay, a sparse matrix kind of thing they create from those data sets, and we can encode them in that matrix. Okay.
I don't know, SKlearn models work directly on a pandas data frame, right? Why are we trying to convert it into a matrix?
No, sorry, the question is, can you repeat the question?
Yeah, sir, I'm asking you that SKlearn models can directly work on data frames, right? So why are we converting it into a matrix?
So I think it is because it requires low space to work with a matrix. So SKlearn works with the can work with a data set. Why are we creating it a matrix? Okay, I'll get back to you on that. Can I get back? I'll post on the discourse. Okay.
So could it
Thanks
be
very
that,
much.
like it is mentioned in the slide, it is used for the text and images, and a data frame probably will not work in the text and
That also is
images.
possible. That is true. That is true. That
Right.
may be also possible that
Right.
it is used for different feature extracting different features from images and all, like Mr. Vivek was telling. Okay, that also is possible.
Sir,
Yes.
hello sir.
Yeah. Who is this?
Sir Abhishek sir.
Okay.
Sir, for this feature hasher, can you please explain with an example?
Feature hasher.
Yes sir.
Okay, let me see. I also don't have right now. In the
Like
collab, it is also not there, na? Okay, I'll check.
for
So,
deep,
like, okay, okay, let me see. I think we had some examples of feature hasher. I'll see. Mm. Oh, they just used a dictatorizer, no? Okay. Huh. So see, feature hasher does what? Let's see one particular. So we have from SKlearn feature extraction, we import. So this is dict vectorizer, is it? Okay, we are talking about feature hasher. So from SKlearn feature extraction, we are importing feature hasher. So we have suppose 10 number of features which we want. Okay, and this is the dictionary like object which we have. We encode the word dog with 1, cat with 2, elephant with 4, and again dog with 2, and run with 5. So let us see what feature hasher does. So it turns sequences of symbolic feature strings into sparse matrices. Okay, and it computes the matrix column corresponding to a name. Okay, fine, and it uses marmar hash 3 encoding technique. So basically it encodes the full dictionary. Okay, let us we can write this code. Suppose we let me.
actually sir, in the case of deep vectorizer, professor gave an example, then it was really easy to visualize. I mean, that kind of example can also suffice, sir.
So dict vectorizer was this example, na? I think I will try. Okay, if it is possible, I'll try. Just let me see whether I can do that. So this is the one which sir has given, right?
Yes, sir.
Let us see what comes here. I'm sorry, the internet is not so good here. It's taking a long time. Yeah. So anyway, most of these both of these techniques, dict vectorizer and feature hasher, they are they encode the thing. Yes. So see, it generates one 10 element array, 10 element array, 1, 2, 3, 4, 5, and then 5 more elements. So 1, 2, 3, 4, 5. Okay. So it also generates a matrix. So corresponding to 96, there is, so 96 is a corresponding to 4. Then 73.9 corresponding to 1. Corresponding to 88.9, there is 3. and corresponding to 81.6, the age is 2. Okay, so that's how basically you can encode it. Similarly, similar thing if we do with dict factorizer. Let's see.
Is this was a sparse matrix?
Yes, yes, this creates a sparse matrix. So if we see with the dict factorizer, on the other hand, okay, I have not data transfer. Achha, I think we have 1 minute. Sorry. See, here actually, as far as I see, I mean the matrices are different. Okay, so for dict factorizer and feature hasher, both will prepare matrices from the data set given, from the dictionary like objects given. But for dict factorizer, the matrix is different than the sparse matrix created by the feature hasher. Okay.
But sir, if we put sparse is equal to true there, would it create a sparse matrix then? In the dict factorizer.
In the let's see what is possible. Let us see. Okay, it is not coming properly, ma'am.
I think you'll have to do 2 array. Underscore transform 2 array to the.
Okay, sure. Let me see. Fit transform we have done. Acha, okay. So you are telling data transform dot to array, right?
Yeah.
Yeah, that is true. No, but then also say, ma'am, it is giving the same matrix.
Yeah,
right?
yes, sir.
Yeah. Is this false? Then also the same. Sorry. Then this is not correct.
So yeah. What exactly is a sparse matrix?
Sparse matrix, though, it will take some time, but sparse matrix is, I think, the matrix which has a huge number of zeros in it. Okay, those are called sparse matrix. So can anyone else explain it better than this? What is sparse matrix? Anyone knows?
I mean, it is a kind of mapping between all the features. Like say we have 4 features, so we will put all the 4 features in the column as well as in the row. Then we will put 0 if we have a true, and 0 if we have a false, and 1 if we have a true. And we used to do it like this in maths 1 to represent a relation between any two, let's say some writers and who have authored some books. So we have a list of books in the row level, and we have list of authors in the column level, and then we used to put 1 for the I mean, then we are getting a table like structure, no?
Yeah.
Yes,
so basically a table
matrix is actually a kind of graph, matrix graph, what we can we have read now. So it is a kind of relationship graph or a mapping graph, whatever you can say.
Yeah. Also, I mean, yeah, the definition which I am getting here is that if it's a matrix in which most of the elements are 0, and if it is most of the elements are non-zero, it will be called a dense matrix. And also, obviously, it will be used for mapping a relation. Okay, as I think Shivashish was also telling. Okay, so that is also one nice characteristics which we can see. Okay.
Right.
So I think the advantage of sparse matrix is that since there are so many zeros, it takes less memory and then is better in processing.
Maybe. I'm not also sure. Maybe that seems valid point. Okay.
Sir, may I ask a question?
Yeah, sure.
For the unlike imputers, when we used imputers, we use the fit and transform method separately, right? Because when we call a fit, it learns the parameters and we transform it, does the transformation. In case of dict vectorizer and feature hasher, are there any parameters to be learned? I mean, the fit and fit transform, aren't they going to produce the same result here?
We have to see. I'm also we have to check. So like here in feature hasher, see, we just use transform. We did not use fit transform. Okay. So like for in this case, okay, so we did not use a fit, right?
Even in dict vectorizer, we can directly use transform.
We can in dict vectorizer. Let us see. We can use. Has no attribute called feature names. So feature names, it is not learning. Okay. And if we use fit transform, then it is giving. So what dict vectorizers are fit transform is required, it seems.
Sir,
and yeah.
Could you please do fit transform in that feature?
Here, hasher. Let us see. This one works. And you can actually change the number of zeros also. The size of the element also, matrix also we can change. Okay. So for feature hasher, the transform and fit transform both works. But for dict vectorizer, only the transform is not working. Okay.
Is there any rule as to what to use where?
Mostly, I think fit transform is okay to apply. Okay, ma'am. So all the data sets that I have seen till now, mostly we use fit transform. It is very less cases where we do not use fit, or I mean, we are only using transform. Okay, so try with fit transform first. If it does not work, we can see if transform is only required. But most of the cases, it is. I think it would be safe to start with fit transform only.
Okay, sir. And so feature hasher and dict vectorizer also can be interchangeably used, is it?
If it is a memory issue, if there is a less amount of memory, then the feature hasher is used.
Okay.
Okay.
Sir.
Yeah.
Sir, in the feature hasher, it is saying that instead of building a hash table, it is applying hash function directly on the. It is applying hash function to determine their column index. So, how is this? I mean, I know how hash functions work, but I mean, how in this case the hash function is applying? I mean, what is the
method? Method, na backside.
Yeah. Yes.
So that actually we are also. I'm also not sure. Okay. You can check with this part. This book. I think this paper may be useful. Okay. I have to. We have to see actually. Let us see what is the paper. So this paper actually introduced feature hashing. So it was invented by Yahoo people. So we have to see what is the background behind. Okay. So we can check that. Yeah.
If you could throw some light on what is hashing, actually, it would be good.
Hashing is basically, I mean, encoding a particular techniques. I mean, it is an encoding technique. Okay, so you just let me search what is hash function. Hash function is used in encoding different data and all. Okay, so that you can, hash function. Yeah, it can be used to map the data of an arbitrary size to a fixed size. So if you have names and different names, you can create different hashes from them, and you can encode those names in different with different numbers. Okay.
Okay.
So I think it is also used in our this thing. Okay.
DBMS.
Sorry.
In
DBMS, is it? Okay, I did not know about that. Also, it is used in blockchain, I think. Okay, So if you want to use, want to explore, if you want to identify or if you want to express a particular block in the blockchain, or the blockchain data you want to establish, you want to express, then those data are encoded in with the hash function. Okay. I think SHA 254 or 234 something is used in that case.
SSA 256.
256. Thank you, sir. Thank you. So yeah, I mean that's what. So hash function is used in encoding, and it is a function which can be used to map arbitrary size data to a fixed size values. Okay.
Yeah, thank you, sir.
Yeah. So anyway, this is a very small part that dict vectorize either say. So what may happen is that in one set dict vectorizer may come and then the other set feature hasher comes. Something like that may happen. Okay. So data handling, obviously we have imputation. So SKlearn.impute, it provides the functionality to fill the missing values. So one more thing, I think, so many people may ask that the collabs are not yet available. So I think one of our student was also made some collab by noting, I think Chandan Kumar has posted, he prepared some collabs based on them, but we have not again verified it. So please proceed at your own risk. But I think that also may help you. Otherwise, we'll show you the collabs here if it is required. So SKlearn.impute provides functionality to fill the missing values. So there is simple imputer and KNN imputer. And the simple imputer has a mean, median, frequent, constant, etc., etc. These strategies. So it can fill the unknown value with a mean. It can fill with median, most frequent, or constant value. Okay. Yeah, someone Parth has posted the sparse matrix link here in chat window. Okay. So obviously, if we can see that 7 plus 2 plus 9 by 4, it has been done, and they get the mean value if we apply strategy equals to mean. So what from here in quiz may come is that we can say what is the syntax. So based on syntax, some things may come. So dash equals strategy equals to dash will lead to this result. Okay. Or what is the output of the following block of code? Then we write the code for strategy equals to mean, and you have to calculate what is the output. Okay. So things like that may come in the quiz and all. KNN imputer also similar things can be done. So in KNN imputer, it is filled with the mean value of the same attribute of in neighbors, that is the in number of closest neighbors are there based on Euclidean distance that we can check. So if you have 138 and etc., etc. Okay. So it will calculate the distance for all of the cases, and it will whatever is the low minimum value, minimum distance value. From there, it will generate the missing values. Okay. So apart from that, what else is there? Feature scaling is there. So this I think is available in the Colab also. Let's go to Colab. So you have standard scalar, max sub scalar, and I think there is another called min max scalar. Before that, let us see whether we have any other things here.
Sir,
so dict vector, yeah, please.
Sir, in K-mean, sir, in
KNN imputer.
In the example, we saw that for one row, we were calculating the distance. So we do that for every row or
for every row. Okay. So like suppose, let us see. One minute. So we have 1, 3, 8, 1, 3, nan 8, 2, 4, 6, 8, nan 3, 5, 7. So first row we take this row. We take this row 1, 2, and nan, the row, first row. So for 1 to nan, we have 3. What are the other remaining parts? This the next 3 rows, right? So for 1, what is the distance of 1? 1 minus 3 whole square. plus 2 minus 4 whole square. Okay. So that is 2.82. So here we are measuring for the first row. So therefore we are measuring for this point. Okay. What is this NaN value that we are calculating? So 1 minus 3 whole square plus 2 minus 4 whole square is 2.82. Again, 3 minus, so there is NaN, so we are not discussing that. Sorry, 1 minus there is NaN, so NaN, this NaN we are not taking. 2 minus 6, so first row minus third row, 2 minus 6 whole square. Then there will be again NaN minus 5 whole square, that we are not doing. Then 1 minus 8 whole square, first row, fourth row. 1 minus 8 whole square plus 2 minus 8 whole square, that is 9.21. So what is our minimum distance? 2.82 is there, and after that there is 4. So for those cases 2.82 is there and there is 4. So what is so what are those two values? One is 3 and another is 5, right? So under 3 NaN value, this NaN value, what is there? There is 3 and there is 5. So what is the average of that? 3 plus 5 by 2 equals to 4. Okay. So therefore it will be 1, 2, and this NaN value will be represented, sorry, it will be replaced with the element 4. Let us see again.
Sir, I have a query specifically that if I'm considering all like n I can change, like 2n or 3n, how many neighbors I will take into consideration?
Yes. I
if I'm
sure.
Yeah, so if I am choosing all the neighbors, then it will just become like a mean kind of thing. Right? It will take the mean of the entire column and impute whatever the NaN value I have there.
If you are applying all the
neighbors, because it is actually taking the
mean. Yes, then it is becoming a mean only. Yes.
Right.
Yes. Okay. So similarly for this NaN value also we have to perform this row NaN 6, 5, this third row, there also we have to perform. What is the minimum distance? So 2 minus 6 whole square, 4 minus 6 whole square, 6 minus 8 whole square and all. So all of those things we have to do properly. So whatever NaN value is there for all those, it will be calculated. So again, what may happen is that for some case, yes, and if you put n neighbors equals to 2, and if you just apply fit transform again, it will immediately give you the transformed feature matrix. Okay. Then we have feature scaling in min max scalar, max absolute value of scalar, and etc. etc. So for standard scalar, what we do, we transform the feature vectors into new feature vector. And what is the formula that we use? We use x minus mu by sigma, where mu is the mean and sigma is the standard deviation. So if we have a 5x1 matrix, sorry, we have a 5x1 matrix and we have sigma equals to √2 and mu equals to 4. If you apply the standard scalar and you apply fit transform again, mostly fit transform is used. Okay. It will immediately scale the full matrix and it will give you a 0 to 1 value. Generally it gives in 0 to 1, so you can see 0, then minus 1 by √2, minus 2 by √2, etc. etc. So it will scale it properly. So it will have a mean equals to 0 and standard deviation to be equals to 1. So and it learns the parameters mu and sigma, etc. etc. Min max scalar again will make the everything in 0 to 1. So x will be shifted to x dash, and this is the formula it will apply. So most of these techniques, they are all scaling techniques. So they will generally scale your data so that if you have suppose a different scale of data, one data in thousands and another data in single digit, then you cannot compare, right? We cannot compare properly. So what these codes do, these code snippets do, is that they they just they scale it so that we can properly calculate we can properly see the interrelation between them.
Sir, I have a doubt in this standard scalar. Suppose I have a feature which is only 1 and 0. Okay, it's a binary. So it doesn't make much sense to use standard scalar out there, right? Is that right?
I mean, it does not make a sense. I don't think.
Yes.
Yeah, I think so. So it's a binary array completely.
Yeah, binary.
Yeah, I think so. You can check. I mean, what is the result coming if we apply scalar? But yeah, I mean, it looks like normal thing only. I mean, need not apply only.
Right.
So similarly, there is min max scalar and max absolute value of the scalar. So it converts everything into in the range -1 to +1. Acha. What else is there? There is so these formula. So what we may give is, please remember these formulas if possible. Please remember them for your quiz. So we may ask that if we apply max absolute value, what is the what is the ultimate result coming? 1 minute. Let me charge my laptop. 1 minute. Yeah. So you can so it may be asked in the quiz that we have applied max absolute value of the scalar or max ab scalar, or so what is the which of the following options is the correct output? Okay, so something like that. Small questions, two marks questions from here. Acha, function transformer, what is there? You can use a user defined function also. So there is something called log2. I think so. Let's see what log2 does. Function transformers. If you search for function transformer, I think there is something called log2 plus log2p, which does what? Function transformer. So it will do a log base 2 whole to the power the mean in the function 1 plus the value which is there. So log 2, I mean log with base 2 of the number, the data plus 1, something like that it will do. Okay, so you have different functions for that. We have 1 minute, let me check. Function transformer. I have to see. Yeah, this is log1p. Okay, so you see what does log1p do? Basically, log1p will actually, let me, where can I see what is log1p? We put log1p. Okay, just check. I think what it does is it is not available here. So what log1p does is, I think it will take 1 plus the value and do a logarithm of that. So similarly, we have here log2. So basically, it will do a log1p will do a log base 10. So log2, I think, will do a log base 2. Okay, we can check it in the code immediately. But so what it generally does, I think, is it will do a logarithmic transformation. So similarly, I mean, any kind of function you have, if you have a particular type of function, you can apply the function and transform the data according to your own wish.
Sir, I have a question here. Before applying this function transformer, isn't it a right process to first check whether all the data points are in the domain of that function? I mean, if I am applying a log function, don't I need to check if the values of all the data points are positive or non-negative? Otherwise, the log won't make sense and it will throw an error.
Yes, obviously it is important to check. See, first we have to see at first what we do. If you have seen the large scale collab, large scale machine learning collab, and if you will see later also. See, at first we have to see what is the describe the data frame we will describe, right? and after that we will first we will load the data, then we will see what are the zero values, what are the nan values that are there. After that we see what is the we will apply describe, so that we see we get a get a hang of what is the uh, maximum value, what is the minimum value, whether we can apply a function, log function. Okay, so yes, if we see that applying log makes sense, obviously we have to first see whether the function range is there. Okay, if we see it makes sense, then only we will apply log. This is just a technique. So in this week we are learning the techniques of the pre-processing, and yes, all of it can be used sequentially or some of it can be used sequentially. Okay, and we can do polynomial transformations as well. So if we have a two degree polynomials, we can get x1 and x2. These are the two variables which we have. We can get see, you can get x1 x2 and x1 x2 x1 into x2, so multiplication of those variables, x1 into x2, x1 into x1, which is x1 square, and x2 into x2, which is x2 square. So this kind so it generates a new feature matrix consisting of all possible polynomial combinations which are there, with degree less than equal to the specified degree. So if you have two, you can get x1 x2 and so 1 2 3 4 5. Okay, so it will generate a feature matrix with 5 features for a 2 feature matrix which was generated, which was given before. Okay.
What is the purpose of this transformation, polynomial transformation? What we will get, I mean, after transforming this,
you get a new feature matrix. I think you can understand the understand and explore the features more in a proper manner, and you can see from lower dimension, you can go from one dimension to a higher dimension, and can explore the data sets more. I think that is the possibility. Okay. Yeah, sorry, I think Shivashish was telling something.
Then I have told.
Oh, okay, okay, sorry. Yeah, someone else was asking a question.
Sir, I think there is a problem in this slide.
Okay.
X dash, I think there should be a 1, because the formula for polynomial transformation, the number of terms after polynomial transformation is number of degrees plus terms C degree. I mean, if it's expressed as, the total number of, if the degree is say D, and total number of terms before the transformation is T, then the formula for the number of terms after transformation will be D plus T choose D. So that gives us 6. I think there should be a 1 in this X dash.
Okay, maybe I'll ask, sir. Okay.
Professor has mentioned that 1 is missing in the video.
Oh, okay. Yeah.
Oh, okay, I didn't.
Yeah, that is true. Yeah, so here also it's the same thing, is it? 1 x1 x2, yeah, x to the power 0 basically should be there.
The polynomial transformation automatically adds a bias term. In both these expressions, the bias comes in.
Okay, sure. Thank you. So similarly, we have different encoding and techniques which we can apply. We have this k-bean discretizer, which can divide a continuous variable into beans and all. Okay, and obviously one hot encoder, it is used to encode the categorical features to a one hot numerical array. Actually, right now we do not have I do not have the presentation. I'll just look into the presentation, and maybe in the next class I'll bring. I had a description of how one hot encoder was working properly. Anyway, so we have 1 2 3 and 1 here. So I think all of you have understood. Still, I'll just that how is this working, but still we'll just describe it once. So we have 3 numbers, 1 2 and 3 here, and so 1 comes in the first column, first row. So obviously in the fourth row, in the matrix, first element is 1. Okay, and then the second column is of 2. Where is 2? In the x dash 4 by 3. Here the second element is 1. So that means 2, the 2 exists in the element 2 exists in the second row of the matrix. The element 3, which is shown in this column, so where does 3 exist? 3 exists in the third column only, third row only. Okay, and in fourth row there is again 1. So therefore, where does 1 exist? 1 only exists in the first column in the fourth row as well. So from there we can see that this is how it works in the one hot encoder. Okay.
Yeah, if we are using a string category in place of 1, 2, 3, if we are using like male, female, or something else, then how it will map? I mean, how it will which one it will consider as first, second, or
I
third?
think that then it works as a, as far as I remember, it works as a, it assigns numerical value. Okay. So what it does is it goes alphabetically increasing. So suppose suppose there are, say, Jack, there is one element Jack.
Lexicographical ordering, you will say.
So what is lexicographical order?
Alphabetically, whatever A, B, C.
So apple is 0, ball B starts with B, that is 1, then cat C starts, that will be 3. Okay, like that. Let me check. I think so, but let me check whether one such example is there, then I can actually show you.
Sir, it was there in the next slide. It will be clear when movie genre example comes.
Movie genre. Suppose we have. Okay.
I think it's a slide
in the collab. It's in the collab. I think. Yeah. 1 minute. So obviously, first we have to add this thing from SKlearn dot whatever encoding techniques which we are using, that we have to import first. Movie genre. Where was the movie genre thing? I saw the movie genre, but Acha, this is multi-level binary. So let me see whether we have one hot encoder. So here you can see that I mean, I'll write the code, but here you can see if you apply this is, so from at first we are doing the from SKlearn.preprocessing import one hot encoder. Okay, that is the one thing on. Then this part is not required, handle unknown ignore. So ENC equals to ENC we are defining as one hot encoder, we are defining as ENC. This is my categorical values: male 1, female 3, female 2. These are the corresponding data sets. So at first we fit the data and then we transform it, enc.transform. And what do we transform? Female 1 and male 4. And once we apply .to array, then we see it will generate 10100. So I think okay, 1 minute. Yeah, so
yeah, the first two columns are for male and female in that array. So it's considering male as 1 and
first two rows. Yes, I think so. So
first two columns.
First column. Okay,
there are 5 columns. Last 3 columns are for 1, 3, and 2.
Okay, last 3 columns are for 1, 3, and okay, sure. I'll also look into it. Yeah. So that is how you can actually work with the categorical data sets. Okay. I think we had some other. I'll just check into it. Okay. We had some other one hot encoder idea also. So anyway, you can see this. So if you have a say suppose here server showing IDs data set. Okay. So you can I think first 5 are Setosa only. Okay. First 5 data sets, first 5 data points are Setosa of the IDs data set only. Okay, if you see the see, if you see the first 5 levels, they are ID setosa. Okay, so similarly for all of the cases in one hot encoder, it will be 11111 only. So setosa is classified is encoded as one value. So therefore, for all the cases, it is for all the 5 cases, it will be treated as it will be one only in the first column. Okay, so that is the kind of thing going on here, and you can apply different okay, here let us observe the difference between ordinal encoding. Achha, in ordinal encoding, again it is coming as 000, etc. So there are two types of encoding techniques. One is one hot encoder and another is ordinal encoder, and some other uh, things are also there. So there is a label encoder which is used for transforming the categorical features into integers, and you can again can generate different matrices based on them. And multi-label binarizer, also the same thing, it encodes the categorical features. So if you have 0 to k number of classes, then you can get 0 to k minus 1 features. And obviously dummy variables we can enter, but we generally have not given much question on dummy variable. I have not seen, but yeah, you can learn. Obviously you can apply, you can add one dummy variable if you need any any particular data set you want to add some one extra variable, say one extra variable you want to add, you can add a dummy variable. Okay, otherwise I think yes. So let me see one other thing which I want to show you.
One thing, this label encoder actually encodes from 0 to k minus 1 strings. But actually it's encoding 1 to 1, means like I have categories like 1 to 6, it will map it like 1 to 0 and 2 to 1 or 6 to 3. But what the benefits I will get? I mean, previously it was also different levels which I can predict. So I'm just making it like some ascending order. So what is the benefit? Why I should do this kind of transformation?
So what is the benefit of label encoder? Is it?
Yes, right.
Okay, it is from 0 to 1. So
Yes.
so I think it will just give you another I mean except that it is giving you in a particular scenario. I mean it is giving in a particular range, the scale is giving in a particular range. That seems the only option, only advantage here. Okay,
Yeah,
I'll
for to
check.
scale it down, or but
Yeah,
otherwise there is no benefit actually,
there
because
is
finally
this.
I have to convert it back to the original level. What is that? What is that?
Mhm,
Because I
mhm.
have to take the level.
Yes, yes, yes. I wanted to show you about pipeline. Let me see, where is pipeline.
So this label encoder, what if you go back to the slide?
I think the previous one.
Yes. No, that collab.
Okay.
So it is showing. So see, the label is so this is my target, the type of the this iris. So I'll have 0, 1, 2 in the same feature in the same column. So in one hot, what happens is it creates for every class, it creates a separate column. So here I am getting in one column only. So it will be a single label.
Okay, but in that case, it will be a matrix.
Yes, in that case, it will create many columns. Yeah. So
okay, so you are telling that is the advantage of.
Yeah, that's why I think label encoder is used, because here it's showing 0, 1, 2. So there are 3 type of iris. So it's showing 0, 1, 2, and it will come in the same column. It's a single column. It won't create multi-labels, multi-label columns.
Okay, that maybe that is also a valid option. I think whoever was asking this seems like a valid point, that it generates one extra matrix for the case. Okay.
I think this is because it's you can see it. I mean, that's the conclusion I get wrong, but I may be wrong, sir.
Yeah, no, I mean that seems like a valid point. Okay, I'll also look, but this seems like a valid point. Okay, so I wanted to show, okay, let us see what else is there. Suppose feature selection we have. So as I was telling, so we can have different, we can select different features in a particular threshold. And so suppose we have, mm, yeah, if you have features with variance more than a particular value, then those features we can remove. If we have a, if we require mean over some particular value, those features we can keep, and so on. We can work on it. Okay. So you can see, I mean, they have, what they have done is they have import a variance threshold, okay, operation, and this variance threshold operation, once they put as threshold equals to 9, then what happens is the transformer removes the edge feature because its variance is below the threshold. Okay. So if you have what is the variance for these cases they have asked. Okay, and you can, so you can basically remove the feature if it is more than the, if the variance is more than a particular value. Also you can select k number of highest scoring features, and you can remove the rest. So if you have k equals to, you put k equals to 2, k equals to 3, whatever. This is for California housing dataset. Again, just a small thing that you can import numpy at first. Then you can, if you want to import California house or any data set which is available online in the SKlearn datasets library, in the SKlearn datasets module, you can just ask to import this, okay, without again read CSV or anything like that. Then another important thing, please do not forget to do this. This is, please import train test split, which is important. So we are splitting the training data and the testing data here, okay. And after that, what we are doing is, we are from the SKlearn feature selection, we are importing the required modules, required libraries that we need, required functions that we need. We have select key based, which will import the uh, key number of best features that has not yet been shown. And then we do a mutual information regression, okay, that also we import. So what is X California and Y California? So X California is, we are importing the, we are fetching the California housing dataset. X and Y are the X California's from up to 2000 elements dataset, and so as Y California. Okay. After that, if you select 3 features, okay, you can select, you can put like that. You can put a variable name equals to select key based. This syntax is important for your, OPPE exam. In that case, you will be asked. So if we put k equals, so please select 3 top features. Okay. So you can see you can say k equals to 3. You can put, and you will get what is the new shape. So what may come in your quiz? In your quiz, it may come that suppose we have given 2000, and this is the code which is given. So up to 2000 elements, 2000 elements, and what is the shape currently 2000 comma 8. So this we will give that the output of this block of code is 2000 comma 8. And once we put k equals to 3, what is the shape of the new element? So whether it is 2000 comma 3, 2000 comma 8, 2000 comma 5, or 1000 comma 9. So you can just say that this is 2000 comma 3. Okay. And similarly, you can get your feature names also from the matrix. So this is these are some questions, these are some topics in the first part. There is select percentile. For OPPE purpose, and yeah, in your quiz it may not be asked, you will not be asked to write the code always, but it is important that you practice and you know the syntax, and you can use the syntax. Okay. So obviously you can know what is the what is the percentile amount you are giving, and based on that you will get some number of features. Okay. So we have some other things. We can apply feature selection with a certain strategy using generic univariate select. And there is another thing called RFE. So in RFE or recursive feature elimination, what we do is we fit a model and then we rank the features. Okay. So once you can rank the feature, you can know that which features you want to remove, right? So if the rank is too good, so suppose 1 to 3, first top 3 features. So top 3 features you want to keep, and the remaining things you want to remove. So you can just see, you can put, you can write like this: from SKlearn.feature selection, we import RFE, and again we import linear regression and all. So again, linear regression will come in week 3 and all. And
Sir,
you can, yeah.
Sir, could you please explain filter based and wrapper based? I mean, what is the difference between them?
Okay, I'll try. Wrapper based selection is where?
This selection, this RFE is a part of wrapper based feature selection. And
Okay.
the previous ones were filter based feature selection.
Okay. Okay, that okay. Okay, if possible, I'll do it today. Otherwise, we'll do it in the next class. Okay, I'll try to do it. Let's see what sir has taught here. Yeah, filter based and wrapper based. The do not contribute can be removed. It leads to decrease in the size of the dataset. Huh? Feature selection provides many APIs. RFCB and select model. Okay, fine. So the variance threshold, select K based, select percentile, these are filter based, and the wrapper based are RFE, RFCB. Okay. Okay. So you can see select K based does all this, removes all but the K highest featuring. So basically they are filtering the features. Okay. Select percentile is removing all but a specified highest scoring percentile. And it is a generic univariate select also performs univariate feature selection using a configurable strategy. Now what happens for wrapper based? Okay, so much on univariate scoring function. Okay. So unlike filter-based method, wrapper-based methods use estimator class rather than a scoring function. Okay, so let us see what is the estimator class. So it uses wrapper-based methods use estimator class rather than a scoring function. Okay, fine. So it uses an estimator class to recursively remove features. So it initially fits an estimator and obtains the importance of the feature from the estimator and removes the least important feature. Then it repeats the process by removing the features one by one until the desired number of features are obtained. Okay, so I think the procedure of working is different for wrapper based as well and the filter based. Filter based method is doing what? Now it is just we are telling it to filter 3 elements. It is just filtering 3 elements. But again, and if we are selecting top 10 percentile, it will just filter out top 10 percentile and will give it. The process of working for wrapper based is separate, right? I mean, as we are seeing, it uses a recursive process, a recursion process. Okay, so that it uses such that it uses an estimator first. So I think here also we have seen that it will use an estimator like linear regression first, and that estimator will be applied every time to to rank the features. Once they are ranked, based on that rank, we can we can remove the features. Okay, so that working procedure maybe is separate for filter based and wrapper based methods. Okay, sir.
Here it says the step equal to 1. So does that mean that the whole estimation will be done in one step?
That I have to check. What does the RFE step mean? That I have to check. We can actually see what is RFE. Just 1 minute, huh? Let me see whether it comes here. Or we can see here RFE. So step. So if step greater than or equal to 1, then step corresponds to the number of features to remove at each iteration. So step means the number of features to remove at each iteration. Okay. So if it is equal to 1, then it corresponds to the number of features to remove. Huh? So it is, yes. So it is at it does not mean at one iteration it is doing. It means that at each iteration it will remove one particular feature from the data set. Okay.
Yes, sir. So, sir, what I understood is that in filter based, we are using some kind of scoring. That means we are using variance or we are using percentile, these things to filter out the features. But in estimator, we are using linear regression.
We are using an estimator class rather than a scoring function. So previously we used a scoring function, top 30 percentile. Okay, this is a particular scoring function we were using. Here we were using, here in wrapper based, we are using an estimator class, and we are applying that recursively. We are using that recursively to remove the features. So we apply an estimator, then in each step we apply the same estimator class, and we keep removing the least important feature. So one by one, at filter based, select top 3. So we selected top 3 from there. Here we are selecting from the below, we are selecting we are removing one by one, we are pruning it. Okay. So we are removing the least important features one by one from the bottom in the wrapper based method. Okay.
Thank you.
Yeah.
And one last thing, sir, in the select percentile, if you go in this, if you go to the respective slide.
Yeah, 1 minute. Yeah, tell me. Here it is. Will it work?
Can you scroll down a bit? Scroll down, please. Scroll down. This one, sir. Yes, sir. So this percentile, the K-based FPR, FDR, can you please explain this one?
That is for this mode, na? Generic univariate select.
Okay.
I will see. I'll see. 1 minute. See, basically, it will all be available here. You can see select percentile. Let us see whether FPR anything is there. So no.
Yes, sir. That was for generic, I think.
Yeah, I think it is for generic univariate. Let's go to generic univariate. Generic univariate. Okay. Sorry. Yeah. Okay. So what is a feature selection mode? Okay, let us see what is feature selection mode.
So it's given on top. That if you go
Which
on
one?
right, if you see, yeah, here it's given.
No,
more.
I mean I want to know more about FPR, FDR. Okay. What are those? I want to know.
So FPR will be in that wrapper.
Sorry.
This is filter. This is filter based, no?
No, this is generic univariate select.
Yeah, but it is a filter based method, right?
No, I mean in generic univariate select we have FPR, FDR, right? These are the modes, feature selection mode.
Okay, FPR. Okay.
this. Now I want to know more about what is FTR. See here, select FPR. So FPR, what it does is it select features on a false positive rate test. So these are all some particular rate test. Okay, so family wise error rate, false discovery rate. I also have to see what are they. Okay, so select FDR. So there is a false discovery rate based on some particular procedure. Okay, I think these are all statistical procedures, sir. Okay, we have to check what are they. Okay, so FTR, you can see here that FTR is a false positive rate test based on, so based on different testing methodology, we are selecting the features here. So the FPR is false positive rate, then false discovery rate is FDR, FW is family wise error rate. Okay, so based on different testing procedure, we can select the features, the number of features and all. Okay, that is my mode. So what are the modes available to us? We can select percentile, we can select k based, k number of based element based features. We can select FPR, we can select based on FDR or FW. Default is percentile. Okay. Yeah. So that is RFE, and similarly we can and we can have RFE CV. So that is a layer of cross validation. Again, cross validation also will come later in our lectures. So I think in the 4th week or 3rd week, cross validation will come. Okay, we'll just check. And so you can select desired number of basically all are same things. You are selecting different number of important features and using mean, median, mode, and other strategies. And you can generate different coefficients and etc. So one interesting thing here which I would like to talk about is pipeline. Pipeline will be important for you. Pipeline, so we will see different pre-processing transformers and all in our course we have seen, or in this week we will see. If you read through if you go through the notebook, you will see. Now the target is we have to chain them together so that on a particular data set we can apply at the same time everything which we require. And one place we apply them, one place we write the code, it will be applicable to all the training, testing, everything data set we can apply the same transformers. Okay, now we can with that we can do with pipeline. So basically you will be given a diagram of a pipeline, and you will be asked that these are the operations we are applying in the pipeline, and you can add two pipelines. There is something called feature union which we can use, and we can get what is the output of the pipeline. Okay, so you can see that intermediate steps of the pipeline, it will be transformers. So that will implement both fit and transform, but the final estimator, the final level only will require to implement fit. Okay, so all the intermediate steps may require fit transform, but the final class of the estimator, that will need only to implement the fitting method. Okay, so it's a very simple thing to work. You have to, okay, I'm sorry. Yeah. So from SKlearn.pipeline we import pipeline, and so this is important. You have to import every time, as I'm sure you know. So what are the transformers we are applying here? We are applying simple imputer, we are applying standard scalar, and so we can designate the pipeline a name. So we have defined the name. We have defined the variable pipe equals to pipeline, and steps equals to estimator. So what are the steps? Steps are the estimators, and what is the estimator value? The estimator has simple imputer and standard scalar. Fine. Now we can access individual steps. we can.
Sir, I have a query that what will be the precedence of the operations there if you scroll up? Uh, just yeah.
So it will be coming from top to bottom. First
Okay.
simple imputer, then standard scalar.
Okay.
So you will be given one image. If you see your graded assignment, there will be image of the pipeline. Okay, so you
Okay.
can actually understand like okay, so this is a block, and after I'll see whether it is there also. I have to see, but it will be like coming from top to bottom. Like here, suppose estimator is equals to simple imputer, then PCA, then regressor. Okay,
Okay.
like that it will come. And
Sir, I have a
so
doubt over here.
yeah.
Sir, in this case, in the previous case, the last one will only fit the.
Sorry.
The regressor will just fit the data, or will it transform the data? Sir, in this case.
No, these are just steps. This we are just we are showing the steps here. Okay, so these are the steps of the pipeline only. Nothing else. We have not fitted the data into the pipeline yet.
Yeah, sir. But in pipelines, it was like the last transformer. I mean, the last API will just fit the data. Will not transform the data.
No, it will give you a transform data. Because intermediate steps we have already transformed, right?
Yeah, sir. Yeah.
Okay. So yeah, so you can calculate actually the number. What are the number of steps which are there in pipeline? That also you can calculate, and you can access different steps. What are the steps which are involved in the pipeline? That also you can calculate. Okay, so all those options are there. We have something called feature union. Feature union also concatenates the results of multiple transformer, and they are both used to feature union and pipeline. They are both used to create complex transformers. Okay, so you can see actually they've defined pipelines. Yes, now see, so we have a particular pipeline here. We have a numerical pipeline where we apply selector, which is a column transformer. Then we apply an imputer, and we apply a standard scalar. In case of categorical pipeline, we apply a column transformer, which consists of a label binarizer only. Okay. Now, how do we add these two pipelines? We put feature union of numerical pipeline and the categorical pipeline. So that is how we are combining two pipelines. Okay, and if you want to see how does the pipeline look like, you will actually be able to see that it will generate a pipeline like this. It will generate the full data pipeline like this. So from SKlearn we import set config, and it will display a HTML representation here, and you can see what is the pass through, what is the simple imputer strategy, it will generate an interactive image of the pipeline, full pipeline. Okay. Then we have handling imbalanced data. In imbalanced data, we can have undersampled data or oversampled data. So sorry, if we have imbalanced data, what we can do to handle imbalanced data? So one is undersampling and oversampling. So if we have some data like that, so already in scaling we have seen that we can do a scaling also to generate different sets of data. So sorry, so we can bring different size of data, different range of data into one particular range. We have mean max scalar, we have max sub scalar, and so on. Okay, and also what we can do is we can undersample or oversample, so that our data are we can have a similar range of data to compare and all. Okay, and process it. So we have, you can see what are we doing. We will demonstrate how to handle imbalance with the help of a wine quality dataset. Wine quality dataset is very famous. It is in the UCI machine learning database. Okay. At first, we have quality versus number of samples data. So for 5 and 6, the number is more than 600, and for 0 and 8, for 3 and 8, the number of quality, the number of sample is obviously less than 100. And so we can undersample the data. Undersampling will refer to sampling from the majority class to keep only a part of the data points. So we can do an undersampling, and we can see what is the data set coming, and so on. Okay, so basically if we have an undersample data, so what if you have an imbalanced data, you can do two procedures. One is undersampling, another is the oversampling, right? So in undersampling, what we do, it refers to the some samples we take from the majority class to keep only a part of those data points, and the remaining data sets, remaining which data which has not that much importance, just not those many data points here, those we focus more on those data points, and we carry on with them. Okay, and if you have a what is the other procedure, that is oversampling. Oversampling will actually, we will replicate some of the points from the minority class in order to increase the cardinality of the minority. So minority class we replicate, we replicate so that its size increases, its importance increases, and that we can, then we can compare them with the with the other data set, with the other column whose importance is much, whose sorry, whose number of data sets, data points are much more. Okay, so up to now, any thoughts on this?
So one doubt. So when should we use which method? Suppose
That
in the
depends
one,
upon the data set.
so in the wine, how will we determine whether we should use oversampling or undersampling? Or should we use both and then see the evaluate the metrics and see which is
I
more?
think it will vary from case to case, sir. Okay. I think it will vary from case to case, and both we can see, and then based on our own jurisdiction, we can move. Sir.
Okay.
So there are some other topics which are also, yeah, you can study on these things as discussed in the lecture. So we have a technique called SMOTE, SMOTE, which is synthetic minority oversampling. So you can apply them to see what are the random points we generate, and so on. But mostly important thing I will tell you for your, I mean, everything is important, all parts are important, but please learn more about pipeline, learn more about sometimes PCA you try to learn, you try to learn about one hot encoder, min max scalar, imputers, simple imputer, knn imputer. Okay, some small questions from there will be asked. So as your quiz is nearing, so that's why I'm talking more about the quiz. So you can be asked like what is the output of a simple imputer code. You can be asked a output of a knn imputer. You can be asked of a something like that, or one hot encoder. Dict vectorizer is very important thing. Dict vectorizer, because that you can calculate without even without use of a computer, right? So those things we can use. Okay, that is one part. The another part which sir has talked about is our data visualization. In data visualization, we can see that there is one or two important things. So one is a histogram, which we already know. I think in stats course we have repeatedly seen what is a histogram, and the other things also we know. One other thing is box plot, right? And other things are like line plot and the column plot, so so obviously I think most of you, many of you already know. Line plots are important, yes. So again, the important thing here is how can we visualize data, right? So, and Colab actually offers a quite good amount of visualization opportunity, right? But that is not that much available in many other softwares. Like say suppose Thony, there is a Python Python software called Thony, which does not give that. It is used for teaching children Python. Okay, that does not give us that much visualization opportunity. Okay. But here in Colab, if you can very properly plot all the data, and if you have a line plot, suppose you want to plot a line plot, how do? You just import NumPy, import pandas, and two very important visualization packages are there. One is Seaborn, another is Matplotlib. Okay, so from Matplotlib we import PyPlot as PLT, and we import Seaborn as SNS. Seaborn is quite important, quite interesting for 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 plotting sometimes interactive and often very colorful data sets. Okay, so if you can generate different different analysis story from the from using Seaborn and all. Now what you can do is you can just put np.leanspace and all. So that is just defining the function. What do we do? It is very simple. I think all of you already have done it. I mean, there is nothing much to say, just to cover for the sake of covering the collapse. So you can generate the figure size of the plot. What you can give a figure size. You can give a color of the plot. So what is the x-axis and what is the fx1 is the function that we are plotting, right? X versus fx1, and similarly x versus fx2 we are plotting. So these are the two sine functions which we have defined before. So fx1 is np dot sine 2 pi x, and fx2 is 2 pi into 2x, right? Sine 2 pi into 2x. So those two will have different phases, and you can see that fx1 has different phase than fx2. One important thing here, so similarly it is there and all. So line plots you can do, I think. One important thing you can learn from here is, let me see whether it is there. Can anyone tell me whether confusion matrix is in this week or the next week? Have you read confusion matrix yet?
Yeah, it was in first week.
It is already taught in first week, right? So confusion matrix you can gather and you can read, and so there are different procedures to visualize confusion matrix as well. Okay, but already you know what is confusion matrix, so should not be much of a problem. So please, again, confusion matrix is quite important topic for all the cases, all your vivas, your quizzes, and your OP exams, and yeah, maybe for the interview also you can look into it. Scatter plot, we can see again scatter plot we can plot, and x equals to fx1, y equals to fx2, whatever. The remaining things are not that much important, I would say. And if you put the line plt dot show, it will help us in generating different plots. Okay, different scatter plots. So plt dot scatter plot. So scatter plot is, I think, in Seaborn. Let me check whether it is in Seaborn. Yeah, I think it is in. It is a part of the Seaborn library. I have to see, but I think it is a part of Seaborn. Yeah. So let us use Seaborn and all. And so from Seaborn you can see different values. Scatter plot. Yeah. So similarly, we can visualize the distribution in 3D as well. If you have the histogram, as we have seen, we can see the histogram in 3D. And this is something called, yeah, this is 3D. Fine. Okay, now see here. So if we have an iris data set, we can do a pair plot. So here all the data sets will be plotted, and you can see here that we have sepal width versus, so sepal length versus sepal length, petal length versus all the petal length versus sepal length, petal length versus sepal width, petal length versus petal length, and petal length versus petal width. So these are the all the plots of of the iris data set. So in your I think in your it's in solve with us or somewhere. So in solve with us also we will do that. We can take one particular data set and we can generate all the, at first we generate all the pair plots, all the plots. Okay, and then based on that we go on, carry on. Acha, box plot. I think we have we studied box plot in the stats course? I think so.
Yes, Avi.
Yes, sure. Thank you, Vivek. Yeah,
Box and
obviously.
whisker.
Yeah. So box plot, as we know, I mean, we'll just glance through it. Box plot has a median and two and one box and two whiskers. Basically, whisker is this two lines which is outside. And what is the one side of the line? What is the one edge of the line? That is minimum value. The other side of the line is maximum value. Outside the minimum and maximum, there are two three data points which are outliers, and except median, there is end of the box represents one end of the box represents the 25th percentile, which is the first quartile, and the top end of the box represents the third quartile, that is 75th percentile. Okay, what else is there? So yes, again, confusion matrix, you can how you can see the confusion matrix, right? So you can just you can put as a heat map, and if you have a np dot array, okay, you can that just put sns dot heat map, what is the cm or confusion matrix, and you can put your different data sets, etc. So one thing is here, you can see this is a heat map. So x equals to np dot random number 50 50. Okay, fine. So we are plotting the covariance and we have a heat map here. Now the C map shows a gray color. Okay, so as it is gray, therefore the full picture, this actually represents your your what do you say, your color theme of your color of your heat map. So it can be, if you generate heat map, if you see heat map, so it can generate different colors based on your don't know where it is, based on your code. It can generate different colors based on your code. So something, it is, I think ocean will be in blue color, and so on. Okay, and you can you can gather, you can show different images also from the you can load sample image and show that also. Okay, but we can't use a heat map here as the image contains 3 channels only, and anyway, that is not that much required, but you can load the sample image and show them. So heat map is there, scatter plot is there, box plot is there, line plot is there, and so these are mostly used for the visualization purpose. Now it can be 2D 3D, whatever be the case, and there are different aspects of how we can generate. We can increase the line weight, we can increase the color, we can change the color, and so on. Those are available. So that is for week 2. Okay,
Sir,
yeah.
is this notebook available in supplementary content?
No, notebook is not yet available. So I think some students have already made a copy. You can check. Notebooks are not available, but you just go through the lectures once.
No, this notebook is not in the video lectures, right? This is like seems to be.
No. Sir has read through the notebooks.
This particular data visualization.
I think so. Yes, I think so.
All right then.
Yeah. Can anyone else comment on that? Whether it is taught in the lecture?
I have not seen all the lectures, so can't comment.
Okay, sure. I mean,
with the titles, I could.
Yeah.
With the, I mean, if I map the titles in this notebook, there is nothing as such as data visualization CBOT.
Okay, see, if you need, then we will provide. Okay, I mean, if you just.
I mean, the content seems to be like the prerequisite, the matplotlib and cbon, which are like prerequisite for the MLP course along with SKlearn library, right? So this is more like information and learning knowledge based notebook.
No. I mean,
Is there any purpose for IITM not to provide this Scholar notebook?
Yeah, so basically the target was so that students can create their own notebooks. Okay, if it is possible. So we can also show you if you need any. So mostly sir has shown all his notebooks in the lecture video. Some portions of the code sir may have skipped, so we can show that in the live sessions. Okay, if you need any particular code snippet, we can show that in the live session. You can take a screenshot and all.
Sir, but apart from the code, there are a lot of information which is stored in these notebooks. I believe if you share, I mean, even if you don't share the codes, it's fine, but the text is very important, I feel.
Yeah, I know, but again, this is not my own decision. And yeah, we have discussed this again before also. But if you need anything, just let us know. Okay, see the videos once. If you need anything, let us know. We will show you. You can take maybe a screenshot or something. You can obviously take. Okay,
sir. The point I am trying to make is in MLT there is week 0 which gives provides notebooks on NumPy.
Yes.
So NumPy is quintessential for MLT course, and similarly, whatever the notebook I am right now seeing, which is data visualization underscore Cborn, I think this belongs to week 0 and should be provided.
Okay. Okay, that's a good suggestion. I can take it up to the team and I can ask them to provide it in week 0. Okay, but I
Thank you.
am not sure whether that will be provided. So in case you need something, see, in case sir has not taught, then obviously you do not need. I mean, these a lot of collabs are made, so it may be that you do not need. Again, if you need something to plot, okay, we will provide it. Okay, we'll just show you and maybe you can take a screenshot or something like that. Okay, yeah. Okay, so I think we also have less time. We will finish in 6 o'clock. So any doubts in activity questions, in any errors you have found, anything like that? Has anyone found any errors or something like that? Let us see the activity questions once. Practice, we will do one thing. We'll do the solve with us and the practice assignment in the Saturday session. Okay. So we'll try to do all of that together. 1 minute. Okay, so first lecture we had what is the output of the code? Again, dict vectorizer. This is the same thing. So obviously you understand that basically, yeah. So this kind of things may come in the quiz. Okay, we give a matrix and we ask you what is the output of the code. So you can apply answer what is the answers which are given. Which API provides functionality to fill missing values? There is a very less chance of this type of question coming in the quiz. Okay, because this you have to remember, which we at this time do not want you to remember. I mean you can remember, but we do not expect you that you will be finished remembering. Which of the following methods is used to replace the missing values of a feature by the average of all other values? So simple imputer, fine. What is the execution of this code? Okay, so this kind of thing. Okay, in p.nan you apply a simple imputer. What is the result after imputation and so on? You can apply. Similarly, for transformed feature matrix, once we apply standard scalar, so it will do a 0, 3, 6. It will calculate and it will generate the option B minus 3 by root 6 to plus 3 by root 6 and so on. So this kind of formula, a little difficult than that, will come in the quiz. Obviously, you understand. So new feature, what is if this is the feature matrix formula, then we will ask you a application of the formula and so on.
I have a query regarding the previous question. You just scroll up a little bit. Yeah, little up. Question number 1. Yeah. So for this standard scalar, do we have to take like standard deviation for population or standard deviation for sample?
Population and sample means, sir, you have to take the standard deviation of the matrix only, the elements of the matrix.
No, actually, there are two different things. So, like, we have to take the standard deviation, like population P, then we have to divide it with the entire set of samples what we have. And if we are taking the standard deviation for sample, then we have to take like n minus 1. That was a elementary thing we have learned in statistics. So if we are taking like standard deviation of sample, then the result will be different. And here they are taking the population. So in every case, do we have to consider this? That I'm asking actually.
Here they are taking of the population. I mean, in all
Yes,
the cases
they are taking population as per the answer. But
I think then we have to take the population only, sir. Okay. Okay. So yeah, and similarly, so all the questions are there: max scalar, function transform, etc., etc. So those are mostly the topics. We have one hot encoder, and what is the dimension of transform feature matrix and all. So as we have 1, 2, 3, and 4, these 4 rows, there are four columns, 4 numbers. Therefore, there will be 5 rows and 4 columns, right? So 5 cross 4 matrix. So a little difficult question than this, but so pipeline is important. Again, RFE, CV we discussed, that is also important. And visualization, even if it is not there, does not make much change. I mean, visualization you already know. So try to plot the data sets if possible. So histogram, box plot, okay, those may heat map may be useful. And if you have then again in the pipeline is very important. Pipeline will come. One question in pipeline you can obviously expect in many exams. So okay, because in pipeline all of the questions are all of the things are applied at the same time, right? So a simple imputer and all that can come. Yeah, so that's it, I think. That's it. So okay, this kind of question may not come in the quiz. Which of the following is all the APIs for feature selection? No, this is okay. So libraries we may not ask. Libraries previous term we used to ask, but we do not want you to every time remember, and with time it will come. Okay, before OPE at least try to remember the libraries, but right now may not be that much important. Okay. Okay, so yeah, so read the slides. Slides are important, and from the collabs also. And whatever issues you face, please see the SKlearn manual first, okay? Because that is the best strategy. That is the best resource for using this for understanding these documents. Okay, so let's stop here. Can we stop here? And we'll start again on Saturday. Yeah.
Yes.
So how many of you are coming in the event? We are having a very huge preparation. Anyone coming from here to the Chennai event, Paradox?
Yes, sir.
Oh, when are you coming? Neeraj?
9th.
Sorry, 9th?
19th May.
19th May. 19th May. Oh, 19th May. What time you are coming?
9 a.m.
9 a.m. I think that there was a Walmart visit now, but I'm not sure. I mean, only 4 people have registered. It may not happen also. Yeah. So 19th May in morning you are coming, and then full day we have a program, and then full 3 days packed up program. Okay. Anyone else? Yes, I'm currently in IITM, Shailesh. You need anything? You can switch on your mic, maybe. Okay, I think Shailesh wanted to ask something. So only Neeraj, one person is coming from here, is it? Okay, Neeraj, where are you coming from?
Delhi, sir.
Delhi. Okay. Oh, okay, nice. Looking forward to meet you here. Manashrita is also coming. Manashrita, great. Please come. We will love to meet all of you. And yeah, I mean, there's a lot of preparation going on. Right now, I will go again and go to, we'll have some meeting and all, I think. So there's so many events which are there. There is a movie, there is a industry interaction, there is a even some ministers also may come, and there's a running event in morning, full packed up 3 days, and there is a lot of discussions and hackathon, and so many things are going on. It is a little bit difficult for us also to keep track of everything. I think so 2000 people are surely coming, which is great. And so have you people do you people know about the BS program, which is transforming? Have you received any information about that? That this 3-year BSc may later be converted to BS or something. Have you heard?
No, sir, not yet, sir.
Okay. So better, then I better not discuss. So there may be an it may be converted, because as the program is getting more traction, more importance from abroad and all, so we are trying to update more. And I think Andrew sir or Bharti ma'am will inform you. Okay, just wait. I mean, some pretty new announcements are coming.
What is can you repeat, sir? What is it getting converted?
I should not. I mean, I
Okay.
should not.
But sir, one professor already said that we are considering for 4-year courses.
Yes. So basically, 4-year courses are being considered, and those courses may be. So we are. I mean, it is not yet finalized and all. Okay, but so some time you may have to come here and do the courses, and so some campus module may also be present. Okay. So that there is a student bonding is there, or some amount of student interaction. See, we are I mean, already the student number, the number of students in the program is more than the campus student number, I think. Okay, so obviously the program is getting quite bigger, and we are trying to establish a intellectual property sale, so that if some of you want to patent something, some of you want to establish a company, then there is a entrepreneurship sale which we are planning. So all these things are there. I mean, this year should be much more interesting than the previous years. Let us see what we can arrange. Okay.
Awesome. Great to hear all these things.
Yeah. I mean, as you understand, right? I mean, we have, I think, 15,000, 14,000 students in the program, and in IIT regular campus we have 10,000. I think is the hostels can accommodate. Okay, so obviously we have more people coming in the program. So all the sales, CFI, and the entrepreneurship sale, patenting sale, all of them, they want to talk with you, they want to discuss with you whatever we can. So let's see. I mean, new nice things are coming up, and let's hope for the best. Okay, let's finish the session here. We'll meet again on Saturday 11 a.m. Okay.
Yes, sir.
And
Thank
please
you.
see the lecture videos. And I asked someone to post a question, post the mail to me the questions. Please post in discourse. We'll try to attend the questions in discourse. Okay, please post. Thank you. Yeah.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Yeah, bye.
Thank you, sir. Have a
Thank you,
nice
sir.
Yeah.